Hello students, now today we'll explain question number 6 and 7 of exercise 13.3 chapter 13 surface area and volume. Now let's see what is there in question number 6. So how many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter. So as according to the question, you see I have already drawn the figure like this. So this, you imagine this as a silver coin. Fine. So this is a silver coin. So this is a silver coin. Now, how many silver coins? That means we do not know how many number of silver coins is required. That is, n number of silver coin is required to make one cuboid whose dimension is also given as 5.5 centimeter into 10 centimeter into 3.5 centimeter. Fine. Now let us see what are the dimensions are given. See, the diameter is given. So diameter of silver coin is given. Okay, that is 1.75 centimeter. Fine. So radius would be what? It would be 1.75 by 2, and that would be equals to 0.875 centimeter. Fine. See, the height is given in millimeter form. So height is given in 0.2 millimeter. So how to change it into the centimeter form? So what we have to do is we have to divide 2 millimeter is given, not 0.2, I guess. No, 0.2 centimeter is given. Fine. Okay. So it is already given in the centimeter form. So no need of changing it. So it is already given in centimeter form. So 0.2 centimeter. Okay. So this is the dimensions given. Now according to the question, what you have to find out is, see, according to the question, that n number of, this is n number, okay, n number of volume of coins required, that would be equals to volume of cuboid. Okay, volume of cuboid, that is n into, now coin is in the shape of a cylinder, isn't it? So it will be pi r square h is equals to length into breadth into height. Fine. Now n into what is pi? Pi is, keep it as 22 by 7 if it is given. Any values is given? No. So 22 by 7. 22 by 7. What is r? R is 0.875 whole square into h is what? 0.2, and this would be equals to 5.5 into 10 into 3.5. Now we have to get the value of this n. So n would be what? 5.5 into 10 into 3.5. Okay, so that would be equals to, just a minute. Okay, now this would be equals to, see, 5.5 into 10 into 5 divided by, this will be divided by this 7 will come here and 22 will come here, and 0.875 whole square by into 0.2. So it will look like n into 5.5 into 10 into 3.5 into 7 by 22 into 0.875 into 0.875 into 0.2. Now after calculation, students, the value of n that you will get is 400. Okay, just do the calculation by yourself. This is very, very important. Okay, so the number of silver coins will be required to make A cuboid with dimension 5 centimeter, 5.5 centimeter into 10 into 3.5 centimeter is 400. Okay, so this is a solution of question number 6. Now let's move on to question number 7. So this is question number 7, boys, as you see the figure. Okay, so let me just read the question first. A cylindrical bucket. So this is a cylindrical bucket. Okay, this is a cylindrical bucket. Cylindrical bucket. Fine. 32 centimeter high. See, this is already, it's marked 32 centimeter height, and with a radius of base 18 centimeter. Fine. So with a radius of base 18 centimeter, it is also marked in the figure, is filled with sand. Now this entire bucket is filled with sand. Now this bucket is emptied. Now after you have emptied the bucket on the ground, and a conical heap of sand is formed. So this type of shape we got, and this is a conical heap, and the dimensions are also given. You see, if the height of the conical heap is given 24 centimeter, then find the radius and the slant height of the heap. So it's very easy, you see. So the volume, so amount of sand which was present in the bucket would be equals to the conical heap, isn't it? Because this amount of sand we got it from this bucket only. Okay, so what we will write is that, so volume of sand in the cylindrical bucket, would be equals to the conical heap. Okay, would be equals to volume, so not volume of conical heap. Fine. So what is the volume of a cylinder? It is pi r square h. Okay, and we'll consider the radius of cylinder as r1 and height of a cylinder as h1, and volume of conical heap would be 1 by 3 pi r2 square h2. Okay, where r2 is a radius of a conical heap and h2 is a height of a conical heap. Fine. So now both the side are having pi values, so we'll reduce this to pi, and in place of r1, so as we already know what is the r1, because the diameter is given 18, so the radius would be, so the radius is already given 18, I guess. Yes, so radius is 18, so it would be 18 square into height is given what? Height is given 32, I guess. Yes, 32. And what is the radius of conical heap? This is what we have to find out, r2 square, and height is given as 24 centimeter. Fine. So we need to transpose this 24 towards this side. So it would be 18 into 32 by 24, and this would be equals to r2 square. Okay, so r2 would be what? Let's reduce these values. So 2 9s are 2 12s are, again 2 9s are 2 6 are. Okay, so 2 is 12, so 3 3s are 3 2s are 6, 2 1s are 2 18s are. Okay, so if I multiply this all values, that is 9 into 3 would be 27, and 27 into 18 would be 486, I guess. Okay, 486. So this answer is going right direction. Just let me check. Okay, 18 into 18 into 32, and 1 by 3 was also there, so I did not transpose the value of 3 out here, so there would be 3 also. This 3 will come to this side as well, so 3 will be here. Okay, So now it will look like R2 square is equals to 3 into, just a minute, 3 into 9 into 3, 3 into 9 into 3 into 18. Okay, now let's so R2 would be equals to the square root of this whole thing, that is 3 into 9 would be what, 3 into 3, there is already one 3 is there, and 18 would be 3 6 are 18, isn't it? So 3 6 are 18 is what, 3 uh, into 2 into 3. Okay, okay, might be I'm doing somewhere wrong. Let's do it again. Okay, so there is some little confusion is there, so let's rub this, let's go to the previous page and let's restart this part. Okay, I guess I've done somewhere wrong. So you see the volume of sand in the cylindrical bucket, okay, that would be equals to pi r square h, and the volume of a conical heap, that would be 1 by 3 pi r square h. Now we'll consider the radius of cylindrical bucket as r1 and height of a cylinder as h1, and conical heap, for conical heap the radius will consider as r2 and h as h2. Okay, now both the side we have a pi value, so we'll reduce this pi. Okay, now we need, our main objective is to get this value, that is r2. Okay, for that we need to transpose this 3 and h2 towards the other side, so it will look like r1 square into h1 into 3 by h2. Okay, and this would be equals to r2 square. Okay, so now what is r square? R square is what, it is 18 into 18. Okay, and what is h? H, we have h of a cylinder is given 32, isn't it? So 32, and we have 3 also here, isn't it? We have 3 also here, so this would be 3, and what is h2 we are having 24, and this would be equals to r2 square. Now let's reduce this. Now 3 ones are 3, 3 eights are 24, and now 8 ones are 8, 8 fours are 32, so we can write r2 square is equals to 18 into 18 into 4. Now if you remove this square, that is r2, then we'll have a square root on the other side, that is 18 into 18 into 4. Now 18 into 18 we can write this as 18 square, and 4 we can write it as 2 square. So r2 would be 18 into 2, so r2 is 36. Okay, I hope all of you have understood this part. So r2 is 36, that means the radius of the conical heap is 36. Now at last we have to find out the slant height of the heap. Okay, so slant height of heap, which is considered as L, that would be equals to root over a square plus r square. Okay, now let's substitute the values. Now what is h? H, we have 24 square, plus what is r, radius, just now we have found out, that is 36 whole square. So 24 square would be 576, isn't it? So just a minute, 24 into 24 is 576, and 36 into 36 is 1296. Now if you add this to number, you will get 1872, okay, that is L is equals to 1872, and if you prime factorize it, that is if you find the square root of this one, it will be 12 root 13 centimeter. Fine. So this is the solution of question number 7. I hope you all have understood. So that's it for today's session. Thank you so much, and God bless you all.